You guessed it. Next part's about fuel. Well, gasoline comes in different grades. It's graded by its octane rating, like 88 or 90, 92, 95, 100. You need a higher octane rating for a higher compression motor, for a higher effective compression, like when it's supercharged or turbocharged. Even though the compression at static may be low, like the ratio, the compression goes way up under boost. Octane is an additive to fuel, like there's pentane, hexane, butane, propane. There's all these different types of fuels, and octane is an additive that causes the fuel to ignite at a higher temperature so that you can have it in a higher compression engine, because compression can ignite fuel, and when you have higher compression you don't want it to ignite by itself, because that's called pre-ignition, and it could push the piston back down the wrong way if it ignites too soon, crack the piston, cause engine damage or total destruction of your engine. Under all circumstances in a gas engine, you want the fuel to be lit by the spark at the right time. Notice the snow. There is two kinds of fuels. There's also winter and summer fuel. Winter fuel is more volatile. It means it evaporates easier, so it's easier for the engine to ignite in the wintertime and possibly start faster. There's a disadvantage to winter gas. It's horrible for racing or higher temperatures, like if you're still using it on a warm day in the spring, or they're selling it in the fall and you get a hot day in the fall. What can happen is, of course, some engines have a fuel rail which is very close to the temperature of the engine where it's radiating from. And that fuel rail gets quite hot, so you get vapor locks, especially after you shut your car off after a hard drive or a hot day or towing with a trailer. The latent heat rises out of the engine and starts to heat the fuel. Well, in that rail, and then it forms vapor pockets, so then when you go to restart your car, it becomes very hot. With a carbureted car, especially on an old V8 engine, they have a crossover passageway on their intake manifold that heats up the carburetor to make the carburetor work properly on cold weather and prevent carb icing. Well, that causes the carburetor to run pretty hot, and after you shut your car off too, sometimes the fuel in the bowl of the carburetor can boil. Then it overflows, runs into your engine and floods it. So then you don't even realize why your engine's not starting, but you actually have to hold your foot to the floor to make it start. Summer fuel rarely ever has problems like that. But of course in extremely cold weather, your engine might not start as quickly, especially if it's an older engine. Another additive fuel might have is stuff like that's built into the fuel, stuff like injector cleaners and stuff like that, and that can help on older vehicles too. And as we all know, if you work on engines or vehicles, gas has a shelf life. That means it goes bad. It goes bad when the cap is not on and it's exposed to air very quickly. You know, it becomes stale. The most volatile parts that help start the engine, the parts that evaporate the easiest, evaporate first. The evaporation of fuel causes cooling, so that causes condensation to actually form on the fuel while it's evaporating, then mixing water with the fuel. And when water mixes with fuel, the fuel becomes very acidic, and that can seize up and corrode your fuel pump and rust the inside of your gas tank. Fuel that's stored in a shed or someplace out of the sun where there isn't big temperature changes, and of course it's sealed, can last the longest. The rule of thumb is if it's perfectly sealed, it's usually still good within a year. Technically, you can use fuel that's older than that, but you may have a problem with gumming up fuel pumps, clogging carburetors, very hard to start. So if you do want to try to resurrect some fuel that's been well sealed but it's older, I would advise just mixing it with some fresh fuel and putting small amounts at a time in your larger fuel tank of your vehicle. Contrary to what you see on Hollywood movies, gas doesn't explode. Yes, the fumes can explode if there's enough air mixed with them in a sealed container, like an empty gas tank, but a full gas tank, a half-full gas tank, a gas tank that's almost full, or whatever, it's not going to blow up. Yes, if the vehicle's on fire, and cars do have a well-sealed system, the tank gets heated up enough, there'll be some pressure form and eventually the tank will split, but it's not really an explosion, it's just going to release a bunch of heated fuel, liquid fuel all over the place. When you see a car blow up that goes off a cliff or in any circumstance in Hollywood like it got shot or anything like that, and it blew up, that was always an auxiliary bomb that was added to the vehicle. Because as you've seen in the real Mythbusters show, it's impossible to make a gas tank blow up even you shoot it with a fiery tracer bullet. But if you do mix gasoline in the form of fumes with enough air or oxygen, 1 gallon of gasoline contains the power of 40 sticks of dynamite. Cool. Now on the other hand, diesel is an oil. It's not an aromatic fuel or one that wants to aerosolize. That means turn into a vaporous particle mass. When you pick up a container of diesel, the same amount of fuel as a container of gasoline, the diesel always weighs about 20% more. It's a denser fuel. And being denser, it contains more energy. That's why diesels get better fuel economy. They also get better fuel economy because they have higher compression, much higher compression. A regular car is 120 psi compression, and a diesel minimum compression is 500 psi. So the tighter the space you can set that explosion off in for any vehicle, higher compression gives you free fuel economy and free power. Any diesel engine will run on any kind of oil so long as it's not too thick or it's too cold out to use that viscosity of oil. It doesn't matter whether it's vegetable oil, lamp oil, kerosene, heating oil, diesel, automatic transmission oil. It makes no difference so long as it's thin enough that it can get pumped through the system and squeezed through those injectors. No modifications required, but if you are using vegetable oil, especially if it's used, there is a process to get the glycerin out of it, so it makes everything in your engine work better and last longer. Another thing is too, diesel doesn't go stale. Because it's an oil, if you leave it in a sealed container, it's fine. You can store it pretty much forever. That's one great thing about that fuel. You know, they tell you at all these oil change places and auto service centers that even if your oil sat in your vehicle for a while, you know, over several months or more than that, you should have it changed anyways. Well, that's not true either. Oil sat in the ground for 65 million years and it's still fine. Like I said, it doesn't wear out, it doesn't get tired. If it doesn't get contaminated by something, it doesn't matter how long it sat in your vehicle. It's probably good, at least if you've checked it. And yes, diesels, of course, don't use spark or any electrical system to start, just to crank the motors. Whenever you compress anything, it gets hotter. So all gases can be compressed that are in vapor form, and that creates enough heat. Diesel lights at a much lower temperature than gasoline, or what's called its auto ignition temperature, where automatically it'll light without spark or flame. And that's why if you put gasoline in a diesel engine, it won't start. It just stops. Gasoline is designed to light at a much higher temperature. Even though diesel lights at a lower temperature, it won't run in a gas engine unless, of course, the engine is very hot. Because the problem being, a gas engine is designed to aerosolize the fuel to a vapor or to a mist, and by the size of the holes in the injectors, by the much lower pressure the injectors have, by the carburetor or whatever, the whole system won't turn diesel into a mist, at least fine enough that the gas engine could light it, unless the engine is very hot. But if you did manage to get diesel into your hot engine and kept it running and it was a gas engine, the other problem is, of course, too, since it does light at a lower temperature, it will pre-ignite and cause a knock and detonation, and that can damage your motor. But most times you'll never get your engine running long enough or good enough for that to happen. Another myth is gas line antifreeze. If your system on your gas system, when you open the cap, always burps or goes psh, stuff like that, you know you've got still a perfectly sealed system. So it's very unlikely vapors have evaporated and caused condensation in your tank, and it's very unlikely too that the gas station sold you fuel with water in it, because they don't pump it out right to the bottom of the tank anyways. So the gas line antifreeze thing in the wintertime really doesn't mean anything. Alcohol is actually a deterrent to starting your car. If you have an alcohol-powered vehicle, you can't even start it in the wintertime unless you add some gas first or have a gas-alcohol mixture. Another thing people want to use as an alternative fuel or racing fuel is alcohol. Alcohol works great, but like I said, it doesn't like cold weather. The disadvantage of alcohol is that it can eat the fuel system parts of your car, like O-rings and rubber hoses and stuff like that. The other disadvantage is you have to burn almost twice as much alcohol to go the same distance as gasoline, so that's often more expensive. But you do get one advantage of burning twice as much more fuel. You will gain 20% horsepower, and the other advantage is that alcohol has a higher octane rating than gasoline. You can get away with about 13.5 to 1 compression in a gasoline engine on alcohol if it's pure. Well, during World War II, there's many parts of Europe, especially in Germany, where they had designed a system to run an engine on what's called wood gasification. This is highly not recommended for any engine that's a good engine or a car you want to keep and use. You can experiment with it and do it with a piece of junk car like the cars on my farm, and it actually does work. It has much less horsepower. A little bit harder to start. You got to make a bigger gap with your spark plugs, and it's so corrosive. Wood gasification will destroy your motor in a short period of time, but if you're desperate and you need transportation and you're living in rough times, it just works by having another wood fire to heat wood in a sealed chamber, which then takes off the gases from it, which are hydrogen rich, and leaves charcoal behind. And these unburnt gases then are plumbed into your engine where the air intake system is, and that's kind of how it works. Natural gas and propane, or LPG, are great fuels for vehicles. They do have 10 to 15% less horsepower output by volume, and of course that means you can't drive as far on the same volume as the fuel that's in a gasoline tank, but they have much less emissions and never go stale, and only of course that's good if the system doesn't leak and you lose your fuel. Hydrogen too is an infinitely clean fuel. It makes no emissions, just water vapor. But the problem is storing it. Hydrogen needs to be several thousand psi pressure to make it liquefy, and hydrogen doesn't contain much energy by volume. So to have the same energy as a car has in its own gas tank, you'd have to have a huge hydrogen tank, and under that much pressure, it's extremely dangerous in an accident or something. Tomorrow's lesson, general automotive repairs and what's true and not true about them.